Thank you so much, Rock. Now I'd like to put some focus on the most safety critical systems in a PT machine that were mentioned already before. And those are the safety systems. So meaning both patient and personnel safety system. Jay, in your opinion, how important is the role of software here?
So you're right. Safety is certainly the most important aspect. I certainly agree with that. How critical is the role of software? And that has been an evolving theme in my life over the last few decades. I remember, first of all, that a non-working machine is not safe, right? So since the patient is not getting treatment. And in the beginning, I believed that the software role in safety was actually a tertiary or a higher redundancy. Wires and AND gates were more reliable and the logic was more tractable. And so it was never acceptable to use software as a mitigation for a highly severe hazard or a fault that was highly probable. But why is that? I mean, software runs as it is written. And that must mean that either it wasn't written well or that there are variables in how it runs which aren't explicitly embedded in how it's written. So I think some confusion and lack of understanding of that has turned software into something which was not fully used for safety in that way. I still do believe that it runs as it is written, including all of the implied timing issues and integration issues that might be built into it. But again, that's a function of how good the software architects are and how well they've incorporated what's important in the design of that system. And so it doesn't mean that a person who is at a accelerator control system knows how to do that. They know how to set magnets and turn on beam, but they don't necessarily know how to understand all the embedded implications of a software system. And then software became an even more important part, in my mind at least, of the safety in when scanning came about, because one needed to do an analysis to enable the handling of statistics, noise, glitches, without unsafely stopping the equipment. You couldn't just do a binary stop or not stop because you would just never finish the treatment. It could be part of a 2 out of 3 logic, or it could have been used to decide that something is safe, even if you think it really isn't safe, or vice versa. So the whole subject of error handling is a much ignored topic, and it's never really been done well, to my knowledge. And it has never been done well by the people who are building PT control systems with the rest of that system. I mean, it needs to be done by people who understand it and know it. However, I actually came more recently to the conclusion that software can be even more effective if it's used as a skeleton iron dome, right? Thinking more like the Star Wars program. If you have a skeleton on the outside that's watching what's going on, there's a lot of possibility if it gets put in the hands of the right people.
Thank you, Jay. Uroš, you've been involved also in the development of many different safety critical software projects for PT systems. So what are the lessons you have learned along the way?
Here, I will agree with Jay that actually software plays more and more the more important role also in the safety. So going from traditional that you have a harder risk control measures, more and more risk control measures are also implemented in the software. For instance, with a recent introduction, let's say, of AI stuff for contouring or for the image registration for the IGRT, you have here the pure software risk control measures. And to rely on software, you need to, as Jay said, you need to have a reliable, well-written software. And to do this, basically, you have a lot of medical standards which you need to follow. So software development for particle therapy system is very complex. Because to write the software for particle therapy itself, it's very complex. You need to understand the domain and all these relations between different devices. And B, all these processes are very strict, and risk management plays the central role. So basically, at the end, your software needs to be really thoroughly and well tested. from the unit level to the system level. You have a unit test, code reviews, static analysis, integration tests, system integration tests, workflow testing, end-to-end testing, a lot of testing. At the end, of course, you have a BMV, and all of this that at the end you can say and prove that your software is safe and efficient to be used for the patient and personnel.